Right, we will complete motion in straight line today. Hopefully, in the same manner, tomorrow also I'll take the sessions. Right, but tomorrow I think we will take the session a little bit late, maybe 8:15, 8:30, and I'll take it till 10:30. Okay, tomorrow I'll take 2 hour session. So something like that we can cover. So some people have written the test again, right? And as you can see, the scores, right? Harshit has scored 156, Srishant has scored 100, Habiba has scored 120, Sadhya has scored 88. I think this is Amatunur, I guess, scored 60. Krishnaveni scored 140. Hemant scored 112, right? And Maria scored 88. Mehreen scored 56. Vaishnav scored 76. These are the scores. I think you got the scores, right, guys? Did you get the scores, everyone? What about the others, guys? Huh? Why are you not writing test again? So these are the scores. If you want to look at them, these are the scores. Some mistakes also you have done, I guess, right? So I am not going into that as of now. So majority might have done all the questions correctly. Soft iron is used in many parts for electrical machines. For soft iron is what? Temporary magnet. Yes or no? So temporary magnet will have what? Hysteresis loss. Low hysteresis loss and high permeability. Yeah, this is only correct answer, guys. Maybe I have kept it wrong, I guess, because it is a ferromagnet, no? So it is correct. This is correct. Okay. So maybe I have given this wrong statement again. Okay. The majority of them have this answer also. A magnetic needle suspended by a single thread is vibrating in the Earth's magnetic field if the temperature of the needle is increased by 770 degrees Celsius. What is going to happen? They are asking. 770 degrees Celsius, it seems. So, what is the temperature? Again, vibration will take place for small changes, right? So, large change in temperature is there. You cannot say that it is going to vibrate again. You should have checked this also, guys. So there's no figure here. Okay, I think most of you have got your doubts also cleared, I believe, for the last test. That there are not many difficult questions in that. If there are any questions, we will look at them probably on Sunday, guys. So from Sunday, Monday onwards, I can take extra time. Whatever classes we have lost for 2 days, not 2 days, I can say 3 days. I think we have lost continuously. So I will cover that for sure. Some part I'm going to cover today. One class I'm covering today, guys. Maybe one class I will cover on Sunday, right? Because I don't think it will be possible on. I don't think it will be possible to take 2 classes tomorrow. So I'll cover in this week. I'll take 2 classes. From next week onwards, we will increase the time and we'll complete the syllabus on time. Okay, right. We'll move on to motion in straight line. So now we are going to discuss to some extent from motion in straight line till gravitation again. These are very very important chapters, right? So these are very important chapters which will fetch you lot of marks again, right? So these are very very crucial chapters also in physics point of view. Those who are thorough enough with these chapters, especially motion in straight line till system of particles, they will be really thorough enough with the entire of physics, guys. Okay, so we will quickly see some quick references about motion in straight line. We'll talk about only linear motion here. Translation again, either the motion can be along x direction or it can be along y direction. If the motion is along y direction, that will be called as motion under gravity. So here major task will be, right, from graphs, which type of graph what we can obtain, right? In the same manner we have uniform motion, you have non-uniform motion equations, right? You have relative motion and motion under gravity. Usually 5 concepts are there in this. So when we talk, किसने किया भैया? Maliha Muskan has muted my mic. How are you able to? Okay, we'll do that later. Position and frame of references. Again, whenever we talk about position, guys, position will always be defined with respect to some reference frame. What do I mean by reference frame? It is simply a coordinate axis, guys. It is simply coordinate axis. And in general, I'm talking about plane also here, guys. So suppose if I want to say position of any object, let us say the object is present somewhere over here in a plane. Will plane have some x coordinate and y coordinate or not? So position of any object will always be defined with respect to some frame of reference. Frame of reference is nothing but a coordinate axis, guys. So what are we going to do here? From the origin to the given point, we are simply going to draw a vector. So this will give us position of point P. So you can consider this is the position vector of point P, and I can represent it as xi cap plus yj cap. If it is in space, I will represent it as xi cap plus yj cap plus zk cap, guys. So position will always be defined with respect to some frame of reference. Frame of reference is nothing but coordinate axis, guys. If I want to define position of any point, either it may be on x-axis, it may be on y-axis, it may be in some plane, it may be in some space. Position of any point will always be defined with respect to origin, guys. Okay, let us talk about displacement now. Basically, most of you people will say it is shortest distance between 2 points. Yeah, it may be shortest distance between 2 points, but actual relation will be it is change in position of an object. What is it? It is basically change in position. Now when I say change in position, I can write displacement as delta r bar beta. So what is change? It will always be final minus initial. I am telling about plane also here, guys. So what we can write final position as, you will write it as x final I cap plus y final j cap, minus you can write x initial I cap plus y initial j cap. You can write something like this. So I'll get it as x final minus x initial I cap plus y final minus y initial j cap. So this will be our displacement vector. If I want to find the magnitude, again, two perpendicular components are there. You will directly write under root of x component square and y component square, right? Although it may be defined as shortest distance between 2 points, I'm not discussing about that, guys. How do you find displacement? Very simple logic. From initial position towards final position, you are just going to draw a vector. What are you going to do? You are just going to draw a vector from initial position to final position, guys. That is how you calculate displacement. Position is always defined with respect to some frame of reference. If there is any change in position, there is displacement. If there is no change in position, there is no displacement. Is that clear, all of you? Yes or no? This is first thing that we basically study related to displacement again. Next thing that we focus on is velocity. Now, by definition, what is velocity by definition? By definition, velocity is rate of change in position or rate of displacement, we can say, guys. Rate, whenever we use a term rate, we talk about differentiation. We write it as dr bar divided by dt. And whenever I say differentiation, guys, we are going to obtain slope from this. So it is slope of position versus time graph. So always remember, in general, slope of position versus time graph is going to give us velocity. It will give us what? Velocity. Then we have average velocity. How do you define average velocity? Basic logic. Average velocity is defined as the total displacement divided by total time, guys. What is it defined as? Total displacement divided by total time. So average velocity can be written as delta r bar, which is our total displacement divided by total time, delta t, you can say. Now what is this? Delta r bar divided by delta t. Is it y2 minus y1 by x2 minus x1 or not? What is y2 minus y1 divided by x2 minus x1? It is slope between what, beta? Slope between 2 points of position versus time graph. It is slope between 2 points of position versus time graph, you can say, or displacement versus time graph also, you can say, guys. Clear, all of you? And whenever the time interval is very small, at that time interval will become at a particular instant. So this is very important again. How do you find instantaneous velocity, beta? When time interval is limited to almost zero. When time interval is limited to almost zero, average velocity is going to become instantaneous velocity, right? Displacement can either be positive, negative, zero. Velocity also can either be positive, negative, zero, right? Right? In the same manner, instantaneous velocity, if I want to find, what will I do? I will limit the time interval to almost zero. Average velocity is delta r bar divided by delta t. This will become dr bar divided by dt. Now, what is this dr bar by dt, beta? it is slope at a particular point again. It is slope at a particular point of position versus time graph. Particular point of which graph? Position versus time graph. How do you find slope at a particular point? Just by drawing a tangent at that point. So from position time graph, what we can calculate? Firstly, we can calculate displacement by checking whether there is a change in position or not. Secondly, we can calculate velocity. How? Slope. We can calculate change in velocity. How? Slope between 2 points of position time graph. We can also find out instantaneous velocity. How? Slope at a particular point of position versus time graph. And how do you find slope at a particular point? At that particular point, we are just going to draw a tangent. Is that clear, everyone? Yes or no, everyone? I hope it is clear, all of you. Am I audible? Hey, Anna. Hello. Motorola sorry marchpera. Next, we have something called as distance again. Basically, whenever you have a straight line motion, guys, in a straight line motion without reversing of direction of motion, right? If the object is continue to move in one particular direction only, then I can say the distance can be given as magnitude of displacement. What? Distance can be given as magnitude of displacement only in one case. What is that particular case, beta? If the object is moving in a straight line without reversing its direction of motion. So basically, what is distance here? It is the total length of the path traversed by the object, right? And always remember, it is always positive, right? Distance can never decrease again. It can never decrease, beta. Okay. And if you take straight line motion, if we consider straight line motion, then what we can take? Velocity, I think you have, it is cleared, everyone. Right. So what do we write distance as? You can take distance as small as beta. I can write it as magnitude of displacement. But there is a clause in this. What is that clause? Only if object is traveling. Only if object travels where? Object travels in one particular direction without reversing. In one particular direction in a straight line, I can say. In a straight line. So if object is traveling in a straight line in one particular direction, then I can say distance will be magnitude of displacement, guys. Clear, all of you? And always remember, this is a very important case again. Distance will always be greater than or equal to magnitude of displacement. Or distance can, again, it is not necessarily always equal to magnitude of displacement. When it is equal, only if the object is traveling in one particular direction. Just like we have average speed, average velocity, and instantaneous velocity, in the same manner we are going to have average speed and instantaneous speed. What was average velocity, beta? It is the ratio of total displacement by total time. However, average speed will be total distance traveled by total time, guys. Now, what is instantaneous speed? Very important case. It is always magnitude of instantaneous velocity. Is distance always magnitude of displacement? Is distance always magnitude of displacement? Yes or no?
No, no, sir.
Distance is not always equal to magnitude of displacement. However, instantaneous speed will always be equal to magnitude of instantaneous velocity. So if I take instantaneous speed, it is always equal to magnitude of instantaneous velocity. Clear? Is that clear, all of you?
Yes.
Right. Then we have acceleration, guys. So what is basically acceleration? Just like velocity is rate of change in position, in the same manner, acceleration will be rate of change in velocity, guys. How will you write acceleration as? By definition again. Whenever a term rate comes into picture, what will use? Differentiation, dv bar by dt. And what will I get from differentiation, beta? I am going to get slope of velocity versus time graph. What are we going to get? So from slope of velocity versus time graph, what we can obtain? Acceleration. In the same manner, What we can obtain from position versus time graph, guys? देखो, slope of position versus time graph in generally will give us velocity again. How will I find acceleration? Slope of velocity versus time graph. So just like we have average velocity, in the same manner I'll get average acceleration. What is average velocity? Delta r bar by delta t. Average acceleration will be delta v bar divided by delta t. So what is delta v bar divided by delta t again? Final velocity minus initial velocity divided by final time minus initial time. What will it give us, guys? Slope between which points again? 2 points of which graph? Velocity versus time graph. So slope between 2 points of velocity versus time graph is going to give us what? Average acceleration. Now, if I want to find instantaneous acceleration, what is the meaning of instantaneous beta? Right? The time interval should almost become zero. Whenever you are limiting the time interval to almost zero, delta will become dv bar by dt. So how will you find average acceleration? Slope between 2 points. How will I find instantaneous acceleration beta? Slope at a particular point of velocity versus time graph will give us what? It will give us instantaneous acceleration. Slope at a particular point of which graph? Velocity versus time graph will give us what? Instantaneous acceleration. These are all points you should remember, guys. Is that clear, all of you? Yes or no? So what we can obtain from velocity versus time graph? In general, we can obtain acceleration. We can find out average acceleration. We can find out instantaneous acceleration. Slope of velocity time graph, acceleration. Slope between 2 points of velocity time graph, average acceleration. Slope at a particular point of velocity time graph, instantaneous acceleration. Is that clear, all of you? Yes or no? Basically, when we talk about instantaneous acceleration, beta, or average acceleration, it is given as the ratio of change in velocity. What is it given as? Ratio of change in velocity to the time taken. Okay. And how will I get instantaneous acceleration? Whenever time interval becomes almost zero, average acceleration will become instantaneous acceleration. Is that clear? Yes or no? Yes or no, beta? Right. Then we move on to equations of motion again. Just now we have seen, if we talk about linear motion, I have written in plane, guys. In vector form, I have written. They have given in just linear motion, x direction motion they have given. So what we can write velocity in x direction as dx by dt. Y direction, dy by dt. Z direction, dz by dt. Acceleration in general, we know it is dv divided by dt. Now, what we can do here is acceleration, we know it is dv divided by dt. Can I multiply into dx by dx? Did I make any change? I'm talking about only x-axis motion. Till now, on the right side, whatever we have written, these were plane motion, guys. The object was moving in a plane. Now I am saying that object is moving only in straight line, right? So can I just rearrange them? If I rearrange them, what will I get? I will get dx by dt into dv divided by dx. What is dx by dt, beta? Dx by dt is nothing but velocity in x direction or not? Or you can say x component of velocity. So I can also write acceleration as v into dv divided by dx. Very important, beta. Again, you see, if I perform integration, what is this integral dx going to give us? These are very important again. What is integral dx going to give us? It is going to give us change in position, which is nothing but displacement. So I'll just write, it will give us the integral dx is nothing but change in position. What is change in position called as, beta? Displacement. So how we can obtain displacement? We can obtain displacement by calculating which area? Area covered under velocity versus time graph with time axis, guys. In the same manner, what is integral dv? Integral dv. If I apply the limits, beta, I am going to get change in velocity. So how will you obtain change in velocity? I am going to obtain change in velocity by calculating area covered under acceleration versus time graph with time axis. Okay. In the same manner, right? What is integral v dv? When I say integral v dv, very, very important, guys. What is this? It is change in velocity square divided by 2. What is this? You can write it as change in velocity square. I'm not saying change in velocity whole square. I'm saying change in velocity square. Okay. Divided by, you are going to get it as 2. So I can write it as delta of v square divided by 2. Delta of v square means v final square minus v initial square. How are we going to get that? From acceleration position graph or acceleration displacement graph. These graphs are important again. Till now we have, on the right side we're talking about slope. If position time graph is given, if position is changing, we can find out displacement. We can also calculate distance. In general, slope of position time graph will give us velocity. Slope between 2 points of position time graph will give us average velocity. Slope at a particular point of position time graph or displacement time graph will give us instantaneous velocity. These things we can find. So from position time graph, you can find displacement, distance, in general velocity, instantaneous velocity, and average velocity, guys. Similarly, velocity time graph is given. What we can find? You can find in general acceleration, average acceleration, instantaneous acceleration. You can also calculate displacement and distance. How? Area. Slopes of velocity time, acceleration. Area of velocity time, either displacement or distance. Clear, all of you? These three graphs are very, very important again. Equations of motion. Clear, everyone? Yes or no? Right. So what is the meaning of uniform motion or uniformly accelerated motion? When I say uniform motion, object has to cover equal distances in equal time intervals. That is called as your uniform motion, guys. Right? So what are the equations? We don't write v is equal to u plus at, guys. If I'm writing v is equal to u plus at, I'm talking about only straight line motion, although they have mentioned it. But in general, we will write it as v bar is equal to u bar plus a bar into t. I'll write S bar. Displacement will be U bar into T plus half into A bar into T square. Then I'll write V bar square will be U bar square plus 2A bar S bar. If the object is not reversing its direction of motion, then distance in nth second will be given as U plus A by 2 into 2n minus 1. These are the four equations of motion that you should be aware. Is that clear, all of you? Yes or no? When is this distance traveled in nth second? If object is not reversing its direction of motion in that nth second, then I can say it is u plus a by 2 into 2n minus 1. But if it is reversing its direction of motion, you cannot use this particular formula. These are equations of uniform motion, guys. V bar is u bar plus a bar t, s bar u bar t plus half a bar t square. V bar square is u bar square plus 2 a bar s bar. And distance traveled in nth second will be u plus a by 2 into 2n minus 1. Is that clear? Yes or no? Now we have something called as average speed and average velocity. I'm not going in detail about these things, guys. Okay, because in very general situation, if you want to find average speed, I will just use the total distance divided by total time. There is no need to remember all cases, guys. Sir, 2v1 v2 by v1 plus v2, 3v1 v2 v3 v divided by v1 v2 plus v2 v3 plus v3 v1. These all are unnecessary to remember again. Basics you should never forget. Average speed you will calculate by using total distance divided by total time. In the same manner, what will average velocity be? It will be given as the ratio of total displacement divided by total time. And as I said just now, displacement is greater than or equal to magnitude of displacement. So I can write average speed will be greater than or equal to magnitude of average velocity. But instantaneous speed, what is it, beta? It is always equal to magnitude of instantaneous velocity. Average speed is not always equal to magnitude of average velocity. Now, don't say in my language, in your language, this may be not equal to, guys. In my language, it is not always equal to. Okay. right? As of now, again, if you go by maths, this symbol is not equal to. No, this is not equal to, guys. It is not always equal to. Please listen. These three statements are very important again. Average speed will always be greater than or equal to magnitude of average velocity. Instantaneous speed will always be equal to magnitude of instantaneous velocity. Average speed not always equal to magnitude of average velocity. Clear, everyone? Yes or no, all of you?
Yes.
Please remember average speed, total distance by total time, average velocity, total displacement by total time. How can you write distance? I can write as speed into time. How can you write displacement? Velocity into time. Right? How can you write velocity? Displacement by time. How can you write speed? Distance by time. Understood, everyone? So I am not asking you people to remember anything. Although if you want to remember, suppose if object is covering equal distances with speed v1 and v2, guys, you see first half distance with speed v1, next half with v2, then I can say average speed will be given as 2v1 v2 divided by v1 plus v2, okay, which is harmonic mean of v1 and v2. Suppose if it is traveling equal time intervals, in first case it is traveling equal distances, in next case it is traveling equal time intervals. You can see here if t1 and t2 are equal, if it is traveling for equal time intervals beta, then average speed will be given as arithmetic mean of v1 and v2. Equal time intervals. First 2 seconds, it is moving with speed 1 meter per second. Next 2 seconds, it is moving with 2 meter per second. So what would be the average speed? 1 plus 2 by 2, 3 by 2, 1.5 meter per second, you can say. If it is covering equal distances, first 10 meters covering with 1 meter per second, next 10 meters covering with 2 meter per second, then I will use 2v1 v2 by v1 plus v2. Right? Equal distances, if it is covering harmonic mean. For equal time intervals it is traveling, then it will be arithmetic mean, guys. Clear, all of you? Yes or no? If there is no change in position, there will never be displacement. Distance and magnitude of displacement will be same only when object is traveling in a particular direction without reversing its direction of motion. Clear, all of you? Yes or no?
Yes.
Graphs also have told you, guys, again. Position time graph is there. What will I get? Slope at a particular point will give us instantaneous velocity. Slope between 2 points will give us average velocity. So as you can see, at a point, position time graph is given. So if I take at a point on position time graph, instantaneous velocity, right? Between 2 points on position time graph, average velocity. This I've already told you. In the same manner, velocity time graph is given. What will I do? Velocity time graph. Again, at a particular point, only one particular point if you are taking, let us take at a point on velocity time graph, I'll get what? Instantaneous acceleration. But if I take 2 points, slope between 2 points on velocity time graph, I'll get average acceleration. Okay. Clear, all of you? Yes or no? And what will area under acceleration versus time graph give us? Most of you will say velocity, guys, which is utter big mistake. Right? It is not going to give us velocity. It will give us change in velocity, guys. Area covered under acceleration versus time graph will give us change in velocity. So as I said just now, we have discussed those points. Here we have seen. Right. See, area covered under velocity time graph, change in position. It will give us displacement. Area covered under acceleration time graph, it will give us change in velocity. And area covered under acceleration position graph, it will give us change in v square by 2, guys. With these points, you should remember again. Next. What is also given, you see, area under speed versus time graph will obviously give us distance again. Now, area under velocity versus time graph is very important, guys. Right? It can give us displacement as well as distance. Now, while you are calculating distance, so or displacement, whatever it may be, usually what do we do is while calculation of displacement, the area above time axis should be considered as positive, and area below time axis should be considered as negative when you are trying to calculate displacement. But when you are trying to find out distance, guys, distance is always length of the path traversed, right? You can again, as already one statement was given, distance can never be decreasing again. It will go on increasing because you're just going to add up the paths traveled again. So velocity time graph is given. So what will I get? Area covered under velocity versus time graph will give us change in position. It may be distance also, it may be displacement also, right? So if you calculate displacement, the area above time axis should be considered as positive, the area below time axis should be considered as negative. In the same manner, if you want to find distance, whether it is area above, whether it is area below, irrespective of area being above time axis or below time axis, while calculating distance you should simply add those areas. As you can see, a1 plus a2 we are doing here, guys. Understood, all of you? Yes or no? Is that clear? Some more important points. Distance time graph is always increasing curve. Distance versus time graph will always be which curve? Increasing curve, guys. The displacement time graph does not show the trajectory of the particle. No, it will follow. Trajectory means path followed. Path followed will be given by which graph, beta? Distance versus time graph or position versus time graph. Clear, all of you? Yes or no? There are some important points that you need to know. Suppose whenever such cases are given, velocity versus time graph, suppose something in this manner is given, guys, then what will you do? What is the meaning? If what we can infer from the diagram, guys, from velocity time graph? Initial velocity, how much is it? Zero. Yes or no? Final velocity also zero. So initially it is at rest, again it is coming back to rest. But you see, is this a straight line? Straight line will have some slope, guys. Because angle made is acute, slope is positive. Slope is positive means here acceleration is positive. Means acceleration is in the direction of velocity. Here you see this straight line. It is a straight line only, but it is making obtuse angle. So it will have negative slope. So here what we can write, acceleration will be negative, or I can say, to be precise, it will be opposite direction of velocity. So if I represent it with the help of a diagram, guys, initially at t is equal to 0. What is 0? U is 0. But from t is equal to 0 to t1, will it be under the effect of constant acceleration or not? Yes, it is going to be under the effect of constant acceleration. So what will happen? For some time t1, will it accelerate, beta? Yes, it will accelerate and it is going to attain some speed. So you can see in this graph, maximum speed is there at t1 only. So the speed attained will be maximum. Now just after it is crossing this time, what is happening? Acceleration is reversing its direction of motion, guys. So here acceleration value is equal to alpha. Here acceleration value became beta. Now velocity and acceleration are in opposite direction. Always remember, velocity, acceleration, if they are in same direction, object moves in the direction of velocity with increasing speed. When velocity and acceleration are in opposite direction, object will move in the direction of velocity with decreasing speed only. So what is going to happen? He will continue to travel till here. Till what time? Total time of the journey, which is given as capital T. Again, you see final velocity again, how much is becoming? 0. So in this particular graph, at one position, you have maximum velocity. So if you know the magnitude of accelerations, guys, what will I write the maximum speed as? You will write it as alpha beta divided by alpha plus beta into capital T beta. Okay, and what we can write? Total length of the journey is given to us already. So what will be total length? Is it traveling in a straight line or not? Yes. So what is the total length of the journey? If I just take, because it is traveling in a straight line without reversing its direction of motion, distance and magnitude of displacement will be same. So I'll get it as half into alpha beta divided by alpha plus beta into t square, which is nothing but half into base into height, guys. Okay, right? And average velocity, if you find out average speed, also you can say it will be maximum speed divided by 2. Clear, all of you? Alpha beta, or you can write it as half of alpha beta divided by alpha plus beta into t. These are this is a very important graph again. Okay, velocity versus time graph is given. How is the velocity initially? 0. Now as time passes, velocity is increasing. At one particular time, it has maximum value. Beyond this time, velocity is decreasing. So because they are straight lines, guys, slope of velocity time graph will give us acceleration. You can do it in this manner. Clear? Yes or no? Yes or no? So from here
Yes.
to here, it will accelerate. From here to here, it will decelerate. Okay. Let us move on to motion under gravity, guys. Again, same thing that we have studied in uniform motion. In place of writing a bar, I will simply write g minus j cap. G will always be acting vertically downwards. Our sign convention will say downward direction is negative. So for us, G will be negative. And also remember, during the course of solving one question, in between solving the question, you cannot change your sign convention. Whatever sign convention you have chosen before starting to do the question, till you solve that question, the sign convention should remain same. Clear, all of you? Question to question, you may vary it, but for one particular question, you cannot change your sign convention. So two cases will be there in this. Object is dropped from a certain height and object is thrown vertically upwards. So when object is dropped from a certain height, after what time is it going to hit the ground? Root over 2h by g. With what speed will it hit the ground, guys? So as you can see, it will be moving under the effect of gravity. So as it reaches here, it is going to attain some speed, guys. Okay, because it is in downward direction, we took it as negative, but the speed with which it is going to hit the ground will be root over 2gh. Clear, everyone? Yes or no? So whenever an object is dropped from a certain height, the time for which it will be traveling will be root over 2h by g. It is also called as time of flight. The speed with which it is going to hit the ground will be given as root over 2gh. Understood, all of you? When is this case? If object is released from height h. Now the next case is particle is projected from ground with velocity v in vertically upward direction. When it is projected vertically upwards, then in that case, what is going to happen, beta? Time of ascent and time of descent, both will be what? Equal. So I can write time of ascent will be equal to time of descent, which will be equal to u divided by g. And what is total time of flight? It is actually time of ascent plus time of descent. Okay, and whenever you are projecting the object vertically upwards, it will be at a maximum separation from the ground. That position is called as maximum height. And what is that given as, beta? U square divided by 2g. Clear? These are the graphs that are associated with your motion under gravity, guys. First graph so easy. First graph easy or not? Motion under gravity when object is projected vertically upwards. So when object is projected vertically upwards, acceleration, whether it is in upward journey or downward journey, g will be negative only, as you can see. G is negative during the entire journey. Velocity versus time graph, guys. The speed will going on decreasing. Again, here it will reverse its direction of motion. Understood? But can speed be negative? This is velocity versus time graph, no? Can speed be negative? No, it cannot be negative. So whatever this part is there, I'll just send it something in this manner. Okay. So this would be speed versus time graph. This is velocity versus time graph. This is speed versus time graph. Clear, everyone? Yes or no?
So what are sign conventions to be followed while doing in this?
ऊपर गया तो पॉजिटिव, नीचे आया तो नेगेटिव, राइट में गया तो पॉजिटिव, लेफ्ट में गया तो नेगेटिव. Perpendicularly outwards positive, perpendicularly inwards negative.
So, but when the ball will be after colliding the surface, when it is coming up, shouldn't it be towards a positive y direction velocity?
हाँ होना चाहिए ना, but this is taken, you are throwing it, yes or no? When you are throwing it, object is moving upwards, so velocity in the upward direction only. So till here it is positive. At maximum height, velocity will become 0, so it became 0. Now again it will move down under the effect of gravity. So before it is hitting the ground, it is negative. After it is hitting the ground, it will start here. You'll get like this. Then you'll get like this. Then you'll get like this. Then you'll get like this. It will continue to move in this manner if it is elastic floor. Okay.
Yes.
Two important cases are there where object is moving under the effect of gravity. Object is dropped from a certain height and object is thrown vertically upwards. Now, when the object is thrown vertically upwards, right, such that it takes t seconds to reach the highest point, it seems. So t seconds to reach the highest point is time of ascent is equal to t here. Now, please remember this, guys. If distance traveled in th second is equal to distance traveled in t plus 1 second, you forget about this third case. So what they are saying, distance traveled in th second is equal to distance traveled in t plus 1 second. So from this, what we can say, I can say time of ascent will be t seconds. Clear? In the same manner, we can use this also. Distance traveled in rth second, we basically write. So here two very important cases. If distance traveled in nth second and distance traveled in n plus 1th second are equal, then what we can say n value as? N value will be time of ascent, which is u divided by g. Clear? Yes or no? In the same manner, this is in case of object rotated vertically. The other one is also in case of object rotated vertically upwards. If distance traveled in rth second, if it is equal to distance traveled in n minus r plus 1th second, guys, this is also a possibility. Distance traveled in r second is equal to distance traveled in n minus r plus 1 second. So here what we can write, then time of flight will be equal to n. Clear? Or I can say capital T value will be equal to n. Understood? Yes or no?
So what is the first one?
First one is if distance traveled in 5th second and 6th second are equal, then I can say time of ascent will be 5 seconds. Okay. Now I am saying distance traveled in second second is equal to distance traveled in 12th second. Then what are we going to get? From there you can find out the value of n again. Okay. Two same consecutive numbers are there, then I can say time of ascent is nth second or n seconds. But you see, these two may be consecutive, may not be consecutive. So that is the reason whenever distance traveled in rth second is equal to distance traveled in n minus r plus 1th second, then I can say time of flight will be n seconds. Clear? Yes or no? Rest all will be based on sign convention only, guys. Okay. So I am not majorly focusing on this again because majority of them are based on sign convention only. Okay, this is one more important case for a body starting from rest and moving uniform acceleration. The distances traveled in 1 second, 2 second, 3 second, etc. 1, 2, 3 seconds. They're not asking first second, second second, third second, guys. Okay, if they're asking first second, second second, third second, you will use the above formula, u plus a by 2 into 2n minus 1. Clear, all of you? So what is the distance? If it is traveling, if it is starting from rest, moving with uniform acceleration, very important, distances traveled S1 to S2 to S3 to S4 to S5, so on. What will this be? 1 is to 2 square is to 3 square is to 4 square is to so on. Clear? This is distances traveled in 1 second, 2 second, 3 second, 4 second, so on. But our interest is to find distance traveled in nth second, which I'll get it as u plus a by 2 into 2n minus 1. Clear, all of you? Understood, everyone? So when they are asking us to find starting from rest, moving with uniform acceleration, they're asking distances covered in in first, second, third, then it will be in the ratio of odd numbers. This is also called as Galileo's law of odd numbers, guys. Last year you got a question based on this again. It is also called as Galileo's law of odd numbers. Clear, everyone? Yes or no? Whenever we use the concept of relative motion, I've already told you many times, guys. Whenever you are using the concept of relative motion, suppose I want to analyze the motion with respect to first object. There are two objects, let us say. I want to analyze the motion with respect to first object. What are the steps you will follow? What will the first step? With whatever respect you are doing, what will you do? Stop the first object, guys. First step, stop the first object. Second step, all quantities of first object. All quantities of which object? First object. All quantities of first object should be given to second object. Should be given to second object. In which direction? In opposite direction. Now what will you do? Now you will see if there is any net force or not. So if there is any net force acting, now I'll directly write net force will be equal to mass times of acceleration. Clear? Yes or no? Understood or not, everyone? Now, one very important case. See this case you see. Particle is dropped. Particle is dropped means will it be moving under the effect of gravity? Yes. Particle is thrown downwards with some initial. Even when you are throwing it downwards, will it again move under the effect of gravity only or not? Yes. So both of them are moving under the effect of gravity. So what we can consider their relative acceleration is 0. Clear, everyone? Yes or no? This point to remember. And also remember, if they are at their maximum separation, the relative velocity will be 0. Okay. Maximum or minimum separation, if they are given, we can directly say minimum velocity will be equal to 0. Clear, all of you? The questions we will solve based on direct formulas only again. So not many things are required in what do we say, relative motion. What is the basic logic? With whatever respect you are finding or analyzing the motion, that object should be considered to be reference. Right? Understood? So whenever we are doing the question with respect to first object, what should I do? We'll stop first object. Right? So what all quantities are there to first object, we will give it to the other objects. In which direction? Opposite direction. Clear, everyone? Yes or no?
Yes.
So this was a basic review of your motion in a straight line, guys. And majorly questions will be solved. Is the board visible? Just give me a second. Am I audible, visible? पूरा नीचे हो गया क्या?
Yes, sir.
Right. So basic things that you should remember from motion in straight line are graphs questions, guys. From which graph, what we can calculate, right? And majorly, many times again, as we see from past 3 years, only one question is being asked from this chapter, and that too it is related to some other topic again, right? A toy car question was asked, right? Motion under gravity, here and there question can be asked, but we cannot completely depend on this chapter. That is the reason overall from kinematics I have taken 3 questions, guys. Okay, so one from motion in straight line, two from motion in a plane, right? Simultaneously laws of motion, either 2 or 3. Work energy for either 2 or 3. System of particles, 3 I have taken, right? 3. Gravitation also 2 or 3 we have taken. So overall almost like 10 questions will be getting covered here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 questions almost. Okay, 3 questions in kinematics. If I take 2 laws of motion, 2 work energy power, you will get 7 questions here. Then 3 questions from system of particles, and 2 questions from gravitation. Like that we can take. Overall, you will get 12 questions, guys. 48 questions you will get again. So within till gravitation only, we are completing almost 60% of our paper, guys. 108 marks we are completing till gravitation. If you are thorough enough, obviously you will get lot of cases, guys. Let us try to solve questions and understand motion in a straight line in a more better manner, guys. Yeah. So hopefully we'll cover till 9 o'clock. I'll take the session in this link. Then, because again, if I continue, no, it will cross 1 GB also, that recording. So we will keep it till 9 o'clock. Then I have already shared another link, guys. So I gave it at 9:05. We can start at 9:05 only, or 9:10, something like that. Let us quickly solve the questions, guys. A particle is moving along x-axis. How is it varying, guys? Position is varying as t sine t. Differentiations are very important. Differentiation and integration are very important in this, guys. They're asking average acceleration. Itla venukuntaru by average acceleration, basic logic. Whenever they are saying average acceleration, our mind should go here. Average acceleration is nothing but change in velocity divided by change in time. And position is given. How can I find velocity? We know it is rate of change in position, beta. So I can write d by dt of t into sine t. Now here you have two functions. One is t, other is sine t. So it is a UV rule, guys. So what is UV rule again? U into derivative of v plus v into derivative of u. What is derivative of t with respect to t? Derivative of t with respect to t will be 1, guys. So what will I get? Velocity expression as t into, what is derivative of sine? Sine derivative is cos t beta plus sine t. D by dt of t is anyhow 1 again. Now this is our expression for velocity. So I need to find what is initial velocity. They're asking t is equal to 0, t is equal to pi by 2. So at t is equal to 0, what will our velocity be? This is 0 anyhow. Plus sine t, what will I get sine t as? Sine 0 is again 0 only beta. Right? Similarly, at pi by 2 seconds again, what will I get final velocity? Cos pi by 2 is again 0 or not? So this term you will get 0, sine pi by 2 will be 1. Finally, you will get it as 1 meter per second. So what will our average acceleration be, beta? We can write average acceleration as how much? Change in velocity. How much is it? 1. In how much time? Pi by 2 seconds or not? So our change in acceleration, average acceleration will be 2 by pi meter per second square. Clear all of you? Did you understand, everyone? UV rule again. Derivative of UV is U into derivative of V plus V into derivative of U. Okay? Understood? Did you understand, all of you?
Yes.
Let us move on to the next question, guys. You see what is the question given here? What I can say? 0 to t1. Can I say, is it velocity constant? Yes or no? So from 0, they're asking velocity time graph is given, displacement time graph they're asking, guys. So from 0 to t1, velocity is constant value or not? So implies what we can write, beta? Dx divided by dt. Will it be constant value? Yes. Implies what we can write dx, beta? You can write it as k into dt. Differentiation is there. In order to remove differentiation, what should we apply? integration. So what will I get? Integral dx. If I say initial position is 0 again, guys. So what will I get from this? Integral dx will be what? X. K is a constant value, can be brought outside. Integral dt will be t. So is x directly proportional to t or not? Which graph will it follow? Straight line passing through origin. No intercept is there again, guys. So it will be straight line passing through origin from where to where? 0 to t1 seconds. Then from t1 to t2 seconds. Just by looking at the graph, right? T1 to T2 seconds. What is happening to speed? What is happening to velocity? It is becoming less negative. Less negative it is becoming means what? It is in anyhow downward direction. Right? It is becoming less negative again. Less negative will have more value or not? So I can say it is increasing. Okay. So you can take something in this case. T1 to T2. Is it a straight line? Yes. Straight line with positive slope and negative intercept. What we can write velocity equation here? I can write it as some k into t, right? Because you have negative intercept. Can I say minus c1 or not? So again, I'm going to apply differentiation here. So what will I get? Dx by dt will be kt minus c1. Okay. So again, if I do differentiation part, guys, so I am going to get here x value as k into t square divided by 2 minus c1 into t. Clear? So as you can see here, x is directly proportional to t square. So it will follow a parabolic path. Same goes with T2 and T3 also, guys. Again, it will be same graph. It will also follow parabolic path. So from 0 to T1, I should have straight line passing through origin. Right? In the same manner, from T1 to T2, I should have parabola. From T2 to T3 also I should have parabola only. So from that, can I say second option will be wrong? Can I say second option is wrong? Yes or no? Wrong. Can I say fourth option is also wrong? Yes. Now what may be correct? Either first one or third one. Right. Now let us take your second equation, guys, from T1 to T2. What did I get x value as? T square. X is directly proportional to T square. Right. So if I plot x versus T graph, how will you get? Again, is it y proportional to x square or not? Y proportional to x square is going to follow which graph beta? Parabola again. So if you take y proportional to x square, y square equal to 4x is like this. So you'll get something in this manner. So either you may get, so y square is proportional to either of this graph you may get, guys. Okay. So I can take third also may be correct, first also may be correct. But you see what is the basic logic? T1 to T2, what is velocity? Negative. How can I find velocity from displacement versus time graph? By drawing a tangent or not? So here also slope obtuse only. Here also slope obtuse only. Okay. Whereas T2 to T3, slope positive. Means velocity should also be positive or not? So here you see, you will get positive. But here also you see you're getting positive only. Where is the mistake now? In both the cases, you are going to get. Which graph can I take now? T1 to T2, x is directly proportional to t square. Velocity positive. Right. So slope should, sorry, T1 to T2 velocity is negative. So slope should be making obtuse angle. Tangent should be making obtuse angle. So here you take, it will make obtuse angle. Here also you take, it will make obtuse angle only. T2 to T3, we got positive again. Which graph will be correct? First one will be correct, guys. Why? Because it is following velocity is increasing. అదే ఇక్కడ కర్వే కదా, అంటే అదే కదా ప్రూవ్ చేసింది, పారాబోలా అని చెప్పేసి కదా ప్రూవ్ చేసింది. Right. So see, always remember this part of the curve will be x square proportional to y or y proportional to x square, you can write. Whereas if I take this part of the curve, this will become y square proportional to x. Okay. So what are we getting here? We are getting y proportional to x square instead of getting x square proportional to y, we are getting y proportional to x square instead of getting y square proportional to x, guys. So I should get this graph only. First graph only will be correct, because if I take this graph, third graph, guys, this is a part of y square proportional to x, which we are not going to obtain. Understood? Yes or no? A police jeep wants to chase a thief's car, which is moving with a speed of 50 meter per second on a straight track, it seems. The separation between the jeep and car is 400 meters. The speed of the jeep required to catch the car is how much they are saying. Again, simple case. You have jeep here, you have car here. Initially, separation between them is how much better? 400 meters. Right? A jeep wants to chase a thief's car, which is moving with speed 40 meter per second. So car is moving with 40 meter per second. Let us say it is moving, jeep is moving with speed v. The speed of the jeep required to catch the car in 20 seconds, they are saying. So let us say this is the situation at t is equal to 0. Jeep is here, car is here. Now what will happen? Jeep has to catch the car after 20 seconds. So let us say after 20 seconds, both jeep and car will be at the same position or not? Yes or no, everyone? Yes, they both are going to be at same position. Now what we can say? Can I say the distance traveled from here to here is distance traveled by what? Car. From here to here, what is it? This again, it is also distance traveled by jeep. So what can I say? Jeep has covered from here to here or not? This is distance traveled by jeep again. So what we can tell from this bit now? Distance traveled by jeep, is it equal to, right, this distance? How much is it? 400 meters or not? Plus distance traveled by car, can I write or not? Did you understand? In order for jeep to catch the car, the distance traveled by jeep should be uh, 400 plus distance traveled by car in the same time. Understood, all of you? What is the distance traveled by jeep? I don't know, right? So can I write it as, because it is traveling with speed v, and for how much time? 20 seconds. Should be equal to 400 plus. What is the distance traveled by car? Again, it is traveling with 40 meter per second. For how much time is it traveling? 20 seconds. Clear, all of you? So v into 20, from 400, can I take 20 common beta? 20 square is how much again? 400. So what we can cancel out from this? 20, 20 and 20. So what will I get the value of v as? You will get it as 60 meter per second. Understood? Understood, everyone?
Yes.
What is given next case? Acceleration time graph is given. So whenever acceleration time graph is given, directly you should remember what we are going to obtain from acceleration time graph. First thing, what we are going to obtain? Acceleration time graph. Area covered will give us change in velocity. Then you move to the other cases, guys. So they are saying acceleration versus time graph of a particle moving along a straight line. If initial velocity of the particle is 5 meter per second, then the velocity at the end of 7 seconds. Now, you please try to understand. Area versus time, I want to find velocity at the end of 7 seconds, guys. So this is again a case of finding the change in velocity only, guys. So will I get this area or not? Is this the area covered under which graph? Right, for calculation of displacement, sorry, for calculation of, again, whenever area time graph is given, above areas you take it as positive, below areas you take it as negative again. So we got, they are asking acceleration time graph is given. Initial velocity is 5 meter per second, then velocity at the end of 7 seconds. So what we can obtain from acceleration time graph? Very basic logic, area of acceleration versus time graph. What is it going to give us? Area of acceleration versus time graph. What is it going to give us? Will it give us change in velocity or not? Yes. So what is the area here we are going to find out? How much is the area? First one you see, 1 into 2. Will I get 2 units? Plus. From 1 to 2 seconds, you see, no area. From 2 to 3, again, how much is it? 1 is one of the side. Other you will write -2, but don't write -2, guys. Even if it is negative, take positive value only, because we have already taken that in the convention. So what will I get? 2, 0. Then what is this? 1 into 2 will be again 2 only. Plus, what is this, guys? Is it trapezium or not? But here, this area is below time axis, so you should take it as negative. Is in the form of trapezium. What will I get? Half into, what is height here? 2 units again. Sum of parallel sides, you see, from 3 to 6, you have 3. From 4 to 5, you have 1. Clear? Plus. Now again below you have triangle, which will give us negative area only. So half into what we can write? What is the base? 1 again. What is the height beta again? -2, but I'll write it as 2 only, guys. What will the area be? How much is it, you see? Above area should be taken as positive. Below area should be taken as negative again. Clear of you? Trapezium 1 we got, I think. Right? And what is this? Half into, we got trapezium as how much beta? 4 to 8. 4 we got. So what is the total area? These two anyhow will get cancelled out. 2 and 2 will get, 4 will be there and 1 will be there. So will I get area as 5 or not? Yes. So what will it give? It is going to give us, this area will give us change in velocity, which is final velocity minus initial velocity, which is 5 meter per second we got. So what is the value of velocity at the end of 7 seconds they're asking, guys. So what we can write, velocity after 7 seconds minus velocity initially should be equal to 5 meter per second. Yes or no, everyone? Area will give us change in velocity, guys. So they're asking us if the initial velocity of the particle is 5 meter per second, what is the velocity at the end of 7 seconds? So what we can write? So implies velocity at the end of 7 seconds will be equal to 5 meter per second plus velocity at 0 seconds. And we already got velocity at 0 seconds as how much? Initially they have given no 5 meter per second. So I got it as 5 plus 5, which is 10 meter per second, guys. Clear, everyone? Whenever acceleration time graph is there, area covered under acceleration time graph with time axis is going to give us change in velocity. Area above positive, area below negative. Clear, everyone?
Yes.
You do this, vehicle travels 1/4 of the total distance with speed v1 and remaining part of it with speed v2. So what is the average speed in this case? Total distance divided by total time or not? So it has traveled 1/4 of the total distance. So total distance anyhow s. So what is the time taken? S by 4. With what speed is it covering? v1 speed. This is time taken. Next, remaining part with speed v2. What is the remaining part? 3s by 4. What is the speed? v2. So what we can get from this? 1 divided by, I'll get it as 3 by 4 f v1 plus 3 by 4 v2. So I'll get it as 1 by 3 into 1 by 4 v1. So I think you can solve for this one anyhow. Yes or no, yaar? So I'll get it as 4 v1 v2 divided by, how much will this be? 3 v2 plus v1 I'll get, I guess. Just check if there is any option like that. 3 v1 plus v2 is there. A vehicle travels 1/4 of the total distance with speed v1 and remaining part of it with speed v2. Okay, total distance it is covering is s. Total time will be s by 4 v1 plus 3s by 4 v2. So this is s by 4, no, this is 1 by 4 here, sorry. This is 1 by 4 s1 and this is 3 by 4 s2. So what we can write it as 4 v1 v2 divided by, so I can take from here 1 by 4 you can take common. I'll get v2 plus 3 v1 guys. Okay. Third option should be the answer for that. Understood all of you? Yes or no?
Yes.
Next question you please see. Elevator of cabin height 1.2 meters starts ascending with acceleration 2 meter per second square. 1 second after the start, a loose bolt starts falling from the ceiling. You see, very simple logic. Let us say elevator is here at what t is equal to 0. Now, is it accelerating upwards or not? So, object is like this. From the bottom, I am just pushing it upwards. So, what will happen? Will it move upwards? Yes or no, guys? Yes. Finally, what will the velocity become? 0 here. Now, will they stay there itself? No, obviously they'll come down or not. They'll be moving under the effect of gravity now. The elevator of cabin height 1.2 meters starts ascending with acceleration 2 meter per second square. 1 second after the start, a loose bolt starts falling from this ceiling. The time after which bolt will hit the floor is how much they're asking. Now, for lift, for elevator, let us say, can I apply equations of motion again? So what will I get? V bar will be equal to U bar plus A bar into T. Yes or no? So I want to find what they have asked. So I want to find velocity, guys. Is there any initial velocity to the lift? No. So what will I get here? Acceleration is there. 2 is there. For how much time is it traveling? 1. So what is the velocity here? 2 meter per second. So after what time? After 1 second, the velocity became 2 meter per second, guys. Okay. So now you see velocity of the elevator with respect to ground is 2 meter per second. What is happening to the bolt? It is being dropped from the ground again. So here we will use relative velocity concept, guys. Velocity of bolt with respect to ground or with respect to, let us say, elevator, guys. What will I get from this? Will it be velocity of boat with respect to ground minus velocity of elevator with respect to ground or not? Yes or no, all of you? So elevator of cabin height 1.2 meters starts ascending with acceleration 2 meter per second square. 1 second after the start, a loose bolt starts falling from the ceiling. So with respect to the ceiling, it is moving under the effect of gravity. The time after which the bolt will hit the floor of the ceiling they are asking. So firstly, after 1 second, I found out the velocity of the elevator with respect to ground. It is moving up, guys. Right? So what we can do? With respect to elevator, is it falling down or not? So what I can write, velocity of the bolt with respect to ground is velocity of bolt with respect to the elevator plus velocity of elevator with respect to ground. Please tell me what is velocity of bolt with respect to elevator? It is starting to fall. Obviously, this will become 0. Right? And what is velocity of elevator with respect to ground? It is equal to 1 second. It is 2. It is moving upwards or not? Yes, 2 j cap. So what will happen to the bolt beta? The bolt will also move upwards only, which is with how much speed? 2 meter per second in j cap. Clear everyone? Now what they are saying, the time after which boat will hit the floor. So now you please see, will bolt also get a velocity same as that of the elevator or not? With what speed is it going to? It will move upwards, same speed as that of the elevator. So it is going to be a case of object thrown vertically upwards from a certain height. I hope you got my point, guys, everyone. I'll just show it in another diagram. Let us say elevator is in ground floor. Okay. You can take till here. So what is the height? 1.2 meters you can write now. This is the elevator. You can consider. And this is situation at t is equal to 0 you can take, guys. This is t is equal to 1 second. It is accelerating upwards with an acceleration 2 meter per second square. Now you see at t is equal to 0, elevator velocity is not there. But for 1 second it is accelerating. So is it going to obtain some speed, guys? Yes, certainly. And what will that speed be? How much? We'll apply this. V is equal to u bar plus a bar into t. How much speed? 2 meter per second. So this is the velocity of the bolt with respect to the elevator after 1 second. Okay, so what we have done? We have found out velocity of the bolt with respect to ground now. With respect to ground, we got how much beta? Again, we got 2 meter per second only. What will be the logic here? I want to find time taken. No? So I'll use S bar is equal to U bar T plus half A bar T square. Yes or no? What is displacement? Initially, the bolt is here. Finally, it is going to fall on the ceiling. So is it minus H or not, beta? Yes or no, all of you? What is initial velocity? At 1 second, 2 in upward direction. Right? What is the time of interval? 1 plus half into what is acceleration? Is it falling on the effect of gravity or not? You can take minus 10. Right? It will be into 1 square. So what are they asking us to find? Height is already given, no? Is height already given? Yes. They're asking us to find time interval, beta. So what we can take here? H value is 1.2 meters, no? So minus 1.2 will be 2t minus 5t square. So from this, you can write the quadratic equation 5t square minus 2t minus 1.2 will be equal to how much beta? 0. From this, can you find the value of time or not? It's a very important concept based on relative velocity concept, guys. Initially, elevator is at rest, it is accelerating. So after 1 second, it will get a speed in upward direction. So at that time, object is dropped. So what will I get if object is dropped? I'll get velocity of the bolt with respect to the elevator is 0. But elevator had some speed, so it means bolt will also get some speed, which will be same as that of the elevator with respect to ground. Understood, all of you?
So why would that be 0?
Which one?
Velocity of bolt with respect to the elevator.
Gir raha hai na? It is just starting to. It is mentioned no here in the question. If you see, it's dropped is given, I guess. Starts falling. It starts falling means obviously it'll take 0 only, no? In that case, if you take this object, right, at this instant, it was at rest only. Okay. Clear, everyone?
Yes, sir.
It's a very good question based on relative velocity concept is also there in this, and general equation of motion is also there in this. If you can just solve for that equation, you'll get the value of time, guys. Clear, everyone? We can use minus b plus or minus under root of b square minus 4ac divided by 2a. We'll do one more question and you can take a 5-minute break and we'll come back, guys. What question is given? You see, displacement time graph is given, right? The section of the graph which corresponds to positive acceleration. Always remember, beta, whenever you have displacement time graph, so basically acceleration is given as rate of change in position. Sorry, it is rate of change in velocity again. So I can also write as d square r by dt square. how position is changing or how slope of position versus time graph is changing will also represent acceleration. Blindly, how you will remember is whichever is in the form of the ice cream cone, acceleration will get negative. Whichever is in the form of the bowl, guys, you will get acceleration positive. So please tell me what is acceleration for AV part? AV part acceleration. Cone shaped ice cream cone, if you take, negative. Right? If you consider bowl, acceleration will be positive. So AB will be what acceleration? Negative. BC also, which acceleration? Negative. CD you will get which acceleration? Positive. DE also you are going to get positive acceleration, guys. So in which part you will get CD as well as DE? So out of the given options, what is correct? D is correct. The displacement time graph is given. What is the meaning of d square r by divided by dt square? Dr bar by dt means directly you'll write slope of position versus time graph. But what is this? This is going to give us rate of change in slope of position versus time graph. The rate of change in slope of position versus time graph will also give us acceleration. How slope of position time graph is changing. Understood all of you? Please remember, blindly remember, ice cream cone, negative, right? Then you have bowl, it will be positive. Clear everyone? Yes or no? Is that clear? Right. So you can join at 9:05 or take a 10-minute break, guys. 9:10 we will join, right? And we'll discuss the other questions again. Please join with the other link, guys. Okay. Clear all of you? Is that clear? You can join at 9:10. Okay. Thank you all.